Hi, I'm Brian, and this is part three in a series of videos on code generators. We've redrawn the drawing to be a little bit more specific here. We're going to go from simple configs, which we talked about in the previous video, and we're going to look at structured text. It's one of the most common, if you're going to build a code generator, it's one of the most common ones. Why is that? Let's talk about that a little bit. It turns out for this one, if you looked at the previous video, we were actually going to parse this with regular expressions line by line. And while it's fairly straightforward, it's a bit brittle. It's a little bit hard to extend later. Want to do layers of things, it gets really hard to read. I'm kind of building a really lazy man's parser. I've got to skip all the way down to DSLs and programming languages, and I can define a grammar, and there are fancy tools like Antler to generate parsers and lexers and really elaborate ecosystems. But I really have to understand my output intent before it's worth making one of those, right? So what we usually end up with is in the middle. We usually end up with some kind of structured text. Our example here is going to be JSON. It's a little chatty, I guess, but it's not as bad as XML. And it's easier to look at, I think, on a whiteboard than YAML, where I'll get myself into trouble with white space. So a lot of our examples, we'll stick to JSON. I didn't transpose all of the simple configs over. I probably will in subsequent drawings. I really wanted to talk about this flow. Input text, right? So we've got some input, these were text files. JSON files are text files. We have collections of input text. Maybe we're going to do some pre-processing. We'll talk about that in a minute. And we're going to run through some rendering. So, now we're going to talk about multiple templates and kind of there's some multiplicity between them. And then we're going to talk about output diversity and intent. So here's a bunch of cool kinds of things we're going to produce. We're going to produce SQL, Python, Java, governance documentation. So this one, we're going to generate some code and then later use that through another code generator to generate really nice documentation. A bunch of other things you could produce. So the lines here say, this object, this is going to go through here, and all those SQLs go up here. And then I'm going to end up running all of them through here. And those are going to end up in Java. And then the same thing for Python. And now what becomes apparent is that I'm programming in my input model and with my templates, because I'm generating, essentially logically synchronized outputs across a number of different tools in my stack. So I can build tables and I can build change scripts. I can build libraries that access them and have object models that represent them. I can build APIs that do so. I can build documentation. And I don't have to keep all of this up to date by hand. I'm just keeping some JSON files up to date. And I mean, that sounds like a win, right? Like 3 JSON files, 3 times 9 output files, substantially more text over here, right? Great. The first problem turns out to be type systems. And these different layers, often will inherently have different type systems. Metadata-based programming like this, talk about code generators, but people talk about metadata-based programming or metadata-based templating. All of those things kind of fall in this category. And you've got to look at your output intent and model and then figure out how much you need to be able to control from the input, right? So we've got string as our data type for last name, and that makes sense in Python and it makes sense in Java, but it doesn't make sense. Well, it makes sense in Hive SQL, right? But it doesn't make sense in relational database SQL. So what are our options? Our first option is set defaults. So anything that is a string, hey, when you go make SQL, default that to varchar 50. I am not advocating that this is a good idea, but for a lot of type mappings, like setting up a reasonable default is the right answer. Another option would be to add it up here into the model, right? So we could say, SQL type. If you've worked with a lot of ORMs, this is a very common combination where what you're doing is manually specifying the output type for the SQL side. There's a lot of variation and variance in the SQL dialects and engines, far more than you find in the programming languages. So, this is a really common convention. But you wouldn't always have to do that, right? Like you could let it default to 50 unless you chose to provide an override. And you could do that in your preprocessor or in your templates, right? So you could save yourself the typing if 50 was okay. Another one that we've run to here, we've got bike. So let's say we're going to go try to produce bikes table. And the first thing that we run into is that we've got a field here called model, but it's data type. I mean, I didn't call it an enum. I just gave a set of fields. This works. This is, a rational way to represent some metadata, but I don't understand how to represent that in SQL. I actually have a couple of different options, right? Like depending on the SQL variant, I actually may be able to define it as an enum type, set those as the legal values. That has pros and cons, right? I could extract that, build like a dimension table, put dates on it. Like there's a bunch of things you can do. As soon as your type system up here allows something like an enum, it becomes very interesting out here, right? So again, when you're thinking about code generators, you're building a code generator, you're thinking about all of the outputs that you want and structurally what you need, and then trying to get like the minimum from that through to what you have to maintain. Because this is all about like typing less and producing more code for the machines. Okay. So that's the general code generating process for, one more. Let's look at PHAS-B, right? PHAS-B has a purchase date and an amount. And, if you're thinking about what this looks like, right? Like you're probably thinking, oh, well, where's the cardinality numbers, right? So like one person probably owns multiple bicycles. Again, we'll come back to this when we talk about visual notation, but like maybe they own this many bicycles. So there's a bit of what does this really mean? We think we intend to link it together. So maybe we need another field here. Maybe we need a link to person and a link to bike. And sorry, I had to like line wrap there. You could, in theory, use just this text to build foreign keys, right? Oh, that's the other thing that's missing, right? Is we're going to go create database tables with last name, first name, DOB. What's the primary key, right? So like maybe we're, traditionalists. We go, well, every table gets a standard primary key and it's table name underscore ID and it's sequential increments. Great. That looks different if we're generating MySQL create table statements with auto IDs versus Oracle, and we're pulling from SQL versus SQL Server, right? So you might find different templates, real kind of some proliferation as we're creating new targets. But, that terminology is actually very similar to programming languages. So, if you're going to go build a new hardware architecture that C++ should run on, what you're figuring out is how to make a compiler that has a new target, right? Because we want the same input languages to come in, programming languages, but those code generators and these renderers, they should be producing machine code that runs on this new specific hardware. So this is the same construct. We're just lifting it up, and rather than trying to generate machine code, we're trying to generate source code. Ultimately, writing source code is tons of fun, but what we almost always are in is situations where lots of it is repetitive. So we're going to use this to continue to get rid of that repetitiveness. So we covered output diversity and intent. Let's cover reuse in the next one. Yeah, let's stop there.